But our next speaker is Dan Larimer. Now, Dan is one of the leading innovators, engineers, and thought leaders in the blockchain space. He is the co-founder of an array of successful blockchain companies, most notably the decentralized exchange BitShares, the social media network Steemit, and Block1, publisher of the EOS protocol, all providing industry and enterprise-grade blockchain solutions utilizing the widely adopted delegated proof-of-stake consensus mechanism which he invented. He is recognized as an industry pioneer, and Dan is one of the high-profile figures in the blockchain arena. At Block1, he is the head architect behind the EOS software, which is engineered to run highly scalable blockchain applications. He is an alum of Virginia Tech, where he currently serves as a guest lecturer and curriculum advisor. Ladies and gentlemen, let's welcome Dan from Block1.
Hello, everyone. It's really great to be here today. I normally don't like to stand behind a podium, but they don't have one of those wireless mics, so we'll see what I can do. Blockchain seems to be the hot topic of the day, and it's a topic that I think has a lot of different meaning, a lot of different interpretations of what it is, what it's good for, what its limitations are. And what I hope to leave you with today is the idea that blockchain is a universal technology, that it fundamentally changes every aspect of every business that we do. And I'm going to show you how the existing infrastructure that we rely on is fundamentally broken and why we need blockchain. See, for the past 25 years, we've been designing systems with servers, and security has been an afterthought. You know, we add passwords, and then we add SSLs to prevent people from getting the passwords as we communicate with the server. And then we find out that people hack servers, and they get the passwords out of the database. So we start hashing the passwords we store in the database, but that's still not good enough. So now we have to rotate our passwords all the time, so that by the time someone brute forces the stolen password database, our passwords have changed. And we keep layering on hack after hack after hack, trying to solve the security problem that's broken at the very start. So let's think about how systems are designed today. When you have a server, we make the assumption the server is secure. And we build in a web application. The web application is usually divided into two pieces. You got the application logic, whether that's your PHP or your Node.js or your Java, and then you've got your database, whether it's your Oracle, your SQL, or whatnot. And the application server is talking to the database, and it's logging in with a password. All the changes to the database are being made through the password of the application server. And then the user talks to the application server, presents credentials to the application server. The application talks to the database, checks do these things match, and if so, it makes all the changes. There's no traceability anywhere in the system. At any time, the admin can modify the database, and even if the admin is trusted, the application logic, what code is running there? Is it reproducible? Right, we have these massive systems, they're taking inputs from all these users, and we have no way of reproducing it to verify that it's legitimate, which creates huge security issues for businesses everywhere. And billions of dollars are being spent trying to lock things down, and it's just not working. Blockchain's the solution to that, but there's a problem that a lot of people believe that blockchains are not scalable enough, they're too difficult to use, or that they're limited in their application. So I want to dispel some of the myths about where blockchain can be used and where it can't be used, because I believe that if you have a multi-user website or service, whether it's private or external, that it needs to be built on a blockchain, and it needs to eliminate passwords and replace it with hardware-based keys. That's the future. So we don't need to be looking at, can blockchain be applied here, can it be applied there? All you have to do is ask yourself, do you have a database? Do you have more than one user? And then you need a blockchain. So a lot of people focus on blockchains only being valuable for businesses and parties that don't trust each other. But what I'm saying here today is that a blockchain can be valuable even if it's only run by a single company, and even if it's completely private within that company, it's still providing value. So let's talk about, blockchain is not just a system for tokens. It's just not just a governance system with all these communities free-flowing. It can be incredibly useful just inside your business. So let's take and look at what it would take to scale. If you're just a traditional, when you're trying to build a traditional database application, there's the belief that, well, blockchains can't scale, so we're just going to use MySQL, we're going to replicate it, we're going to rely on that data integrity to give us our security. But it doesn't work. You have to have your developers secure the communication. They've got to apologize. All right, I'm gonna step back out and talk about an analogy of one of the ways that I was hacked when I was dealing with an exchange. So you log in to the exchange. Start back. One morning, late at night, I get an email. And in that email, it says that my password has been requested to be reset. I'm like, that's odd. I didn't request that. The next thing I know, I'm getting an email that my password has been successfully reset. I'm like, uh-oh, this isn't good. Then, about 30 seconds later, I get another email saying that a request has been made to withdraw all my Bitcoin from the exchange. Uh-oh. Because 30 seconds later, I get an email that, oh, thank you, successfully authorized, your Bitcoin has been withdrawn. I just lost, I think about $80,000 worth of Bitcoin I had on this exchange. And I asked, how could this happen? At first, I thought maybe it was my email account that was hacked. I log on to Google, and Google says, yep, no unknown IP addresses or locations have logged into your email. So how exactly did my email get hacked? Or how did my funds from the exchange get stolen? Well, it turns out that the exchange itself was hacked, and that rather than hacking my email, they were sniffing on the outgoing email from the exchange. So when the exchange generated the email to send to me, they got the code right out and sent it right back in. And when they send me the SMS text message, they pulled it right out of the exchange database, fed it back in, and my tokens were lost. Now, fortunately, this exchange recognized that they were to blame because my email was secured by multi-factor authentication, and they realized that they had a compromise. But this is the exact same problem that every single business has when they try to authenticate their users. When you're trying to authenticate your users, you want to know that they're the ones that are authorizing things, right? Imagine you're Twitter, and you're an executive that's using Twitter, and all of a sudden a tweet goes out, and that tweet does something that moves the markets, potentially illegal if you're a publicly traded company, you're not allowed to say certain things. Who's to blame? Did the user publish it? Did someone inside Twitter manipulate the database? Did a hacker come in and change the records? This is the problem we have when we rely on password-based authentication, or even when we use multi-factor authentication, whether it's SMS or Authy or Google Authenticator, all those tools we have today. And the problem is we don't have an immutable, traceable audit log of signed, authenticated messages from each user. Every system we have in society can be modeled after a sheet of paper system, where people are making signed statements. Do this, do this. Given a set of signed statements and the order in which they were received and processed, combined with deterministic business logic, we can reach consensus. We can know what's supposed to happen, what's not supposed to happen. The power of blockchain is really combining consensus, deterministic execution, and signed messages that can be independently verified. It's those technologies coming together that provide the security that we're looking for. And that security exists whether it's a blockchain run by a single company or whether it's a decentralized network shared by many companies. That security exists whether it's all private or whether you commit publicly to the hashes of your data. So if you have a blockchain and you're logging every single message from every single user and you're signing those messages, now you can prove to anyone who said what and when. Now you can agree on the outcome that's supposed to happen. So what if you wanted to achieve some of these things without blockchain? Because that's the argument that a lot of people make, is that we don't need blockchain. I can do all that with a regular database. I know you can use your YubiKey to log into your Google account. Isn't that secure? And the answer is, all of our existing technologies, they're authenticating the connection to the application server. They're not providing an audit trail that anyone can come afterward and verify that you did indeed authorize it. It's like showing your ID to enter the club. He says, yes, you're allowed in. Now you can go in and do things, but no one can prove what happened after the fact. So it's like you show up to a bank, and the bank teller verifies your identity, and you say, hey, I'd like to transfer some money from one account to the next. The bank teller enters it on the computer, transfers the money. Where's the record that they actually verified your identity? Now, it gets worse than that, because the bank teller doesn't actually just transfer the money. The bank teller turns around and talks to a system. Now, if we were to, this would be the database. They say, hey, database, update the balance from this balance to this balance. The database, even if you logged everything that happened in the database, it's just tracking the reads and writes. It's not tracking the intent of the users in the system. And that's a really big gap. So if you're trying to build a system without a blockchain and you want to have traceability, auditability, you need to have deterministic code. Deterministic code is incredibly difficult to write. This is the thing that blockchain developers are experts in, but the typical developer who's building your web application is not an expert in writing deterministic code, and it's really, really easy to get it wrong. So the purpose of deterministic code is that if you're given the same inputs, you get the same outputs. If your code's not deterministic, then you can get two different interpretations of the world. One database says this is my balance, and over here my balance is something else. And sometimes even a single bit of difference can compound over many, many actions to be very different states, particularly if you're dealing with financial systems, exchanges, and so forth. So writing deterministic code is actually the heart of consensus. Right? Consensus is two parts: agree on the order in which things came in, and then agree on the rules that we're going to apply to that to derive the state. In some cases, it's what your balance is. Other cases, what you said on social media, when you said it, how many points you earn, whatnot. It might be an auction, who got the bid in first. Or it might be your school and your grades, or certifications, your identity. All these different things are derived calculations based on the sequence in which people submitted their data. So deterministic code is critical. But if you try to write deterministic code in existing frameworks, right, if you're going to use React or Node.js or Java, and the developer allows their code to touch anything, a memory address, a random number, anything that's not coming from the database itself, and you've just introduced non-determinism. You can't reproduce the calculations based on the user inputs to derive the database state in a way that you can trace and prove to an auditor, prove to yourself that your business is doing what it said it would do. Because that's what this is all about, really. is we've got businesses, we say we're going to do things a certain way, and now we need to be able to prove to ourselves that we are indeed doing them that way. And then when billions of dollars go missing, we know exactly how and why they went missing. When there's a bug and something doesn't go down right, you want to know why, you want to be able to reproduce it. And if you've lost track of who said what and when, you can't come out and fix it after the fact. The database is just wrong, and now you got a real mess on your hands. So if you can't, while it might be possible to have really talented developers implement a really secure database solution that salts all your passwords right, encrypts all your connections right, makes your business logic deterministic, logs all the user inputs, does everything that a blockchain does but is not a blockchain, it's going to be very costly to build your applications that way. So what we're doing at Block 1 with EOS.io is we're creating software that makes it really easy for anyone to build web applications on top of a database that's highly performant, that runs in a deterministic manner, and produces an audit trail where every user action is signed by a private key. This is a future where passwords are eliminated, and that makes things even easier for end users. So if you're dealing with passwords, it's already a problem. You're already doing it wrong. And we've been doing passwords from the very beginning, from the very first web services. So it's not a question of, is blockchain applicable in my industry? If you have a database and you have multiple users, a blockchain is 100% necessary. And it's not a question of, can blockchain scale? Because blockchain has to scale. Because trying to reproduce the benefits of what blockchain provides without doing a blockchain is a lot of work, and it's like asking your developers to just roll your own password management system, just roll your own second-factor authentication, roll your own cryptography. You don't do that because it's a lot of extra work. It's incredibly error-prone. So what we're doing is we're taking blockchain and we're making it fast. We're making it easy to develop for, so that you can get all the benefits of traceability, auditability, ease of use, decentralization if you want it, without having to roll it all yourself and try to secure your systems. So this is a very fundamental technology, and if you're not investigating how you're going to move your system to blockchain, it's going to be a big problem when it becomes best practices. It's my opinion that eventually failure to move your systems onto blockchain is like putting passwords directly in your database without salting it, like hosting a bank without SSL. It's potentially negligence in the future once the technology is there. And I know the technology is just about there, because with EOS.io we're processing tens of thousands of writes a second of user actions. We're supporting large databases. We're getting the development environments in place. So it's not too long before you'll be able to build and deploy web applications, mobile applications that use a blockchain application/database server on the back end, faster and cheaper than you can do with today's existing technology. So that's why I think the technology is going. That's why I think blockchain is critical for every business that cares about integrity of its business model, accountability for its actions. And there's another element to blockchain, is that it actually allows your business to communicate more effectively with other businesses. Because if your blockchain publishes if your business publishes the hash of its blockchain, it can now prove things to other businesses. And this is what we call inter-blockchain communication, when I can prove that a transaction was signed by my business, and then you can use it in your business. You know, something as simple as wanting to verify that someone's got a degree, right? Today, you go to a web portal in the college, have it mail a copy of your transcript in a sealed envelope to your employer. But with the blockchain, I could just prove that I have a degree because I've got a transaction. can just submit that and they can verify it independently. So blockchain is fundamental, and it can be used to transform our voting systems, our money, our accounting systems, our HR systems. Every database that we use today can benefit from blockchain. And it will benefit from blockchain. And it has benefits even if it's completely private, run by a single individual or multiple parties within a company or across multiple companies, or completely open and decentralized manner. Blockchain still has benefits. So with that, I'd like to open the floor for any questions that anyone has about where they think blockchain can't be used, or if they have any questions about what I'm saying with respect to its universal application. And we've got a mic here.
So raise your hands. Do you have a question?
I just wondered whether or not you've approached any of the EHR vendors, the electronic healthcare records vendors, to talk through the benefits of what you're proposing here.
So health records, classified documents, these are all things that have a certain permission structure associated with it. And what blockchains do is they allow you to authenticate users and verify signatures. So have not directly approached that, but this question is a very common question. So I started with BitShares creating a decentralized exchange. And then I went to social media. And if you can do those two things, you can do pretty much anything. But what I realized is it was a lot of work to have to create a whole new blockchain to do social media after creating one blockchain for doing an exchange, which is why we created ESIO, so that it's a lot easier for the next person, whether they're doing healthcare, to quickly adopt a blockchain technology without having to be an expert in creating the blockchain technology. So I think that's a wonderful application. And it's actually an application where a private blockchain makes a lot of sense. You don't want the health records to be public, but you do want a record of everyone who accesses them. And you want to make sure that they are authorized and the ability to retract it. And those are all things that can be tracked on a blockchain.
Next.
Hello, my name is Ryan Cooper. I'm founder of DeVille Crypto Solutions, and I work at Bowie State University. I run the Blockchain Association Club there. And I just had a question. Is your company willing to work with colleges and HBCUs to assist with use case solutions that we come up with based on your platform that allows blockchain solutions? It fast tracks that.
Yeah, we're working with Virginia Tech and some students there to create various solutions for blockchains, everything from combining the token model to create local currencies on campus, to use those currencies to prioritize scheduling in classes, for tracking football tickets and be able to sell and transfer tickets. There's a lot of things you can do at universities, and Block One does work with Virginia Tech and potentially other universities to see these types of things created. But once again, a university has multiple users. It has a database. It has lots of databases, everything from class schedules to grades to attendance records. All those things are perfect things to integrate into blockchain.
Hey, Dan, just for the benefit of the audience, could you talk a little bit about your upcoming voice product and the advantages it has over a centralized social network?
Sure. So Voice is a social media platform 2.0. It's the idea is to put the content on the blockchain, to have real identities, so that everyone knows it's real, everyone knows who said what, but also so there can be an incentive model to incentivize good content contribution. Everyone knows that these are real likes, and to secure the account. The example I gave earlier, if you're an executive of a public traded company and all of a sudden your Twitter account says funding secured, did you actually say that or did you not? These are all things that would be solved on Voice which rewards users for contributing content that are liked by other people. And that is a huge benefit of blockchain. And if it can be used for social media, it can be used for HR, it can be used for medical records. So, and it's also demonstrating that blockchain is ready for prime time. We can handle large user bases on blockchains, and pretty soon the inter-blockchain communication will really allow scaling and cooperation between different companies with their own blockchains. But having everything on a public record helps in the censorship, and that's huge because, well, a single website might have to take it down. If it's on a blockchain, everyone still knows you said it. A blockchain's kind of like a radio station in that way. It's broadcasting on the air. Everyone can be recording it. And if you can authenticate what everyone's saying, that yes, someone really did say that on the air, then everyone can reach consensus because they all have a copy, they all know the order, and they can all authenticate who said what. And then once it's been broadcast, there's no takebacks. And the role of consensus algorithms, whether it's proof of work or delegated proof of stake, is basically DJ, who gets to go on the air and broadcast the messages. And if you're a private company, well, you get to decide. But if you're a decentralized system, then you can use voting to decide, or maybe who pays the highest fee to decide. But it's fundamentally, there's a broadcast channel. You're broadcasting to the world. And when the whole world can receive the broadcast, know the order that it was broadcast in, and verify who said what because they're using public key cryptography, it's really powerful.
Hi, this is Kirsten Pamales Langenbrunner. So I was curious as to what your thoughts are on second layer solutions that are interoperable with multiple blockchains, because one thing that I've noticed at specifically this conference is I've been talking to so many people who are building second layer solutions as opposed to a couple years ago where everyone's like building their own blockchain. So I just wanted to know, what role do you think second layer solutions that are just globally interoperable, what role do they have in creating more adoption and specifically enterprise?
Sure, all right. Second layer, let's define the layers. You've got a blockchain, and the blockchain, I guess, is considered the first layer. And on that layer, you've got a record of all the transactions that are going on. And the idea is if that layer can't scale, you try to do it at a layer above it. Well, the layer above it is another blockchain, in my view. It's every user, in theory, in this room could have their own blockchain. Imagine if every time you said something to anyone, it was logged in your own personal blockchain and you were signing to it, and everyone could verify that you said this then. Then it's just a matter of each person understanding, where their blockchain is relative to everyone else. All right, and so now you got two blockchain. Who's the first layer? Who's the second layer? Then there's applications that try to deal with the private keys, and this is your client, and it's basically your voice, because your keys and what you're signing is actually critically important, because you can be deceived into signing something that you didn't mean to sign. Right? Sign this paper and you're signing a hash, and it's all this stuff. So you need to have a tool in your toolkit to show you the contract that you're signing and make sure that you really are agreeing to what you think you're agreeing to. And that's another layer. But what I see too often happen is people say, well, the second layer is, I'm going to use a regular database in traditional systems where blockchain doesn't scale. And I think that's actually a step in the wrong direction. It's saying, well, blockchain can't do this, so therefore we're going to use this other thing. We're going to call it another layer, and so forth. So without getting into particular details about what's at each layer, I think this layered approach is only really relevant if you've got a view of one blockchain to rule them all, whether it's EOS or Ethereum or Bitcoin, and everything else has to be a layer on top of that. But if your view that each and every one of us and every single company can have one or multiple blockchains and they're all talking to each other, then there are no layers. Everything's blockchain and key management, and then deterministic inferrals of state from once we've established the global order of who said what and when, and as well as agreed upon what code we're going to use to interpret it. All kinds of things are possible. We don't need to rely on traditional databases to make up for blockchains aren't fast enough. Ironically, when we're developing voice, we ran into a problem where the Postgres, the database we were mirroring the state of the blockchain into, is actually the bottleneck, not the blockchain itself. And that's because the databases, there's the read, write. I got to read something, do some calculations, right? That back and forth is actually very, very slow on traditional databases. But when you can take the application logic and the database, put it in the same process in a smart contract, that's stored procedures on steroids. It allows you to have very fast read, do some logic, write systems in an atomic fashion that you can't do with regular databases. Regular databases scale very well for lots of parallel reads, but they're still bottlenecked for any writes where you've got lock contention. But that's where you have multiple blockchains and there is no layers.
Thanks, Dan. JP Adiku here. Just a question, given we're at this historic venue, arguably, and the subject is future of money, governance, and law. I was just wondering, from the perspective of how you run Block 1, what role you think government can have to facilitate further innovation, adoption, and incentivization of this technology?
Sure.
Thank you.
So I think blockchain is fundamental, and it could really transform integrity in our society. It can bring integrity to our financial system, to the banking system. We shouldn't have banks going bankrupt and say, I don't know how the segregated funds of trillions of dollars disappeared. We shouldn't have the Pentagon telling us, oh, we lost $2 trillion, don't know where that went. These types of situations where we expect accountability, voting, with blockchain, it's possible to have a voting system that's secure at the information level and doesn't depend upon a particular voting machine or a particular app. You should be able to write your own client to cast your own vote and to count the votes and still have your voting privacy. That's all possible from blockchain. That's all things that are relevant to the government. But I think it's really critical that people understand that blockchain, there's nothing special about blockchain from a regulatory perspective. It's just another application/database technology put into one. And those applications can be highly regulated applications like an exchange, or very unregulated things like maybe your book club wants to track who's doing what. So the technology itself does not need to be regulated. If there were to be any regulations that could be helpful, it might be mandating blockchain adoption. It might be requiring use of hardware keys. It might be requiring provably fair elections. Those are things that I think the government could do. But limiting blockchain or treating blockchain-based tokens differently than non-blockchain-based tokens, I think is really blurring the lines, as well, causing a lot of confusion. We don't need a bit license that's treating these things separate from any other security out there. Something's either a security or it's not. It doesn't matter what database you're using to track it. It doesn't matter that it's more secure. See, blockchains have allowed things to become so much more efficient that it's been a lot easier to create things that you can trust, that have value. You could create Bitcoin on SQL and a server somewhere, but it'd have no value. The same thing built on blockchain has tremendous value. But if you try to do Bitcoin on a server and actually even back it by real gold, those types of things get shut down and treated differently, even though fundamentally it's just technology. It's just a tool, and the regulations don't need to account for that other than best practices like SSL and so forth.
Thank you very much.
Thank you.